Going forward, there's ways to design our roads and map and place our roads in ways that could have much less conflicts with wildlife.
Well, we do landscape modeling because the landscape is very diverse in some ways, but also very similar and homogeneous in another. So it's largely a forested part of the world. And wildlife can move in many different directions, and they can move in many different pathways to get from here to there. The question is, how do I set priorities? Can I be strategic about this? And so sometimes that strategy is sort of linking up similar areas. Sometimes it's taking into account already protected land and trying to then use that and link those up because you've already got a head start there.
While it would be great to think that we can make every part of our roadways more permeable for wildlife, it's not realistic, nor is it necessary. We need to prioritize our limited transportation investments. We need to know where the most suitable pieces of habitat are. Where are the movement corridors and the most significant wildlife populations? What roads are the biggest barriers? And are the adjacent habitats protected from future development? There are many different scales when it comes to planning and mapping for wildlife connectivity. Here are some examples of regional and statewide approaches to prioritization.
The Staying Connected initiative is a public-private, binational collaboration of natural resource and transportation agencies, conservation organizations, and academic partners working to maintain and restore habitat connectivity across the Northern Appalachians and beyond. The partnership involves multiple strategies and scales. At the large scale, partners have identified priority habitat linkages that are critical for connectivity across the region. These linkages connect the largest, most intact core forests and serve as priorities for long-term species movement. The Staying Connected initiative's geographic focus is the northernmost end of the Appalachian region, which several partners, including the Nature Conservancy, have identified as the most important large-scale corridor for wildlife movement in eastern North America.
One initiative that we've heard about in other states that you have that sounds pretty unique is the CHANGE program. Could you tell us about the CHANGE program?
Yeah, sure. So CHANGE stands for Connecting Habitat Across New Jersey.
All right.
And it's a project that's administered by our DEP, Fish and Wildlife, and specifically our Endangered and Non-Game Species Program. And basically, it's a project that has a couple main tools that help ourselves as implementers, as well as the public, see where and how to make our landscape here in New Jersey more connected, to protect the habitat connectivity and restore it in a number of cases. So there's this map, this interactive map that folks can use, an online map, or can be downloaded for folks that use GIS, and then it has an accompanying guidance document that helps guide then decision-making, about how to protect and restore habitat connectivity in the realms of habitat protection, habitat management, and then road mitigation. Those are kind of the three main actions that we talk a lot about.
In New Hampshire, the Fish and Game Department developed a GIS-based wildlife corridor map showing areas that connect core wildlife habitat. The core wildlife habitat blocks are areas over 50 acres in size that are priority habitats in the New Hampshire Wildlife Action Plan. The modeling team used Linkage Mapper, which is a GIS tool for habitat connectivity analysis, to map connections between the core wildlife habitats. Finally, the corridors where wildlife are predicted to move most easily were identified. This resulted in a wildlife corridors map. The map is used to prioritize habitat connectivity and land protection efforts.
Amphibians are some of the wildlife that are most affected by roads. They tend to be small, low profile. They often move around in the dark. Sometimes they move in large numbers across roads, and motorists just don't see them. And on top of that, they're some of the most threatened vertebrates around the world. So it's a big concern.
So Chris, I hear that you guys have developed a computer model to try to alert you to areas that might have significant amphibian crossings?
That's right, Jim. We developed a predictive model using GIS and LiDAR to take a look at the state and identify areas where there might be potential large-scale amphibian crossings across roads, across our roads, across town roads, across railroads. We use that as a screening tool during the resource ID process. When we have a project come through, we'll take a look at that and a lot of our other screening tools to see if there are resources that are involved. If that scores high on a project, then we'll go out and ground truth the results.
In addition to planning for connectivity on a landscape level, we also learned about several site-specific planning tools. Here are a few examples.
One of the exciting projects that the Fish and Wildlife Department, the Agency of Transportation, and the Nature Conservancy and the University of Vermont have been working on together over the past several years has been what we call the terrestrial passage screening tool. And so that's looking at every single structure on the state system and assessing it for its landscape scale connectivity, site level connectivity, and then specific structure characteristics that make it more usable or not to wildlife species. And so then we can score each structure at these different scales and get a sense of the extent to which it's important. Now, structures that have a good landscape score and a really bad structure score, well, those are really ripe for retrofit or replacement.
These are ways that science can inform, work on the ground. This is usually based on GIS data. That's whatever's available, and sometimes it doesn't tell us everything. So going out on the ground, seeing what it looks like, looking and saying, is this truly an opportunity or is this not, is just as important. One of the issues that we discovered a couple of decades ago was that it would be a lot easier to think about connectivity if we had a better sense of what the culverts and bridges were out there now and what were they doing already in terms of being passable. And so we developed approaches for assessing roads crossings, culverts and bridges for aquatic connectivity and for passage for terrestrial wildlife. Yeah, well, these protocols that we developed for assessing road stream crossings became a program called the North Atlantic Aquatic Connectivity Collaborative.
So, one of the projects that you're working on for the Nature Conservancy, could you tell us something about that project?
Sure. So we're working on a regional prioritization of road infrastructure needs. So it's not just culverts, it's bridges, but it's also broader roadway improvement projects that if we identify them and see that there are connectivity benefits by doing something a bit differently, we can engage or have partners engage on those projects as long as we identify them soon enough to try to work on different ways to mitigate the barrier effect of roads. It's a state-based tool. It sits on a website for anybody to go in and identify different sites and start screening, is there a terrestrial wildlife connectivity benefit here? Is there an aquatic organism passage barrier here that we could mitigate? And be able to filter all of these transportation needs on a web map platform, so it's very user-friendly.
In addition to looking at the landscape and site-specific conditions, if possible to investigate, it's helpful to know how wildlife currently interacts with roads. Let's look at some of the wildlife survey techniques that are available.
Yeah, at Maine DOT, we use environmental DNA testing to look for kind of rare species and threatened species in areas where we have upcoming DOT projects. So we like it because it's a way we can make informed decisions without having to kind of do more extensive surveys on whether something is there or not. Freshwater mussels is a fun one because if you've dealt with those, the only way to do surveys is to employ a whole dive team most of the time. Yeah. And even then, they're cryptic, hard to find. You dive all day and miss them. You know, it's really specialized work. And then or you could take a water sample, and that's so sensitive you can find one of them within a mile or something, like, you know, and so you're able to really utilize a tool that's less invasive, that's easier, that's cheaper, and is actually more accurate.
These cameras have been deployed continuously since 2014. We have crunched the data and have picked up a whole variety of species at this location, including moose, deer, bobcat, and interestingly, we tend to get different species moving at different places along the slope. Up here is where we'll get bobcat moving, where they don't mind being over top of the rock. Down on the shelf proper is where we see most of the deer movement. And then down closer to the river, we're seeing mink, river otter, and so forth. So it's really interesting to think about the different, you know, in a slope that's this long, to think about the gradation of where different species tend to cross under the bridge. We were a little bit worried about vandalism at this site. And our usual swivel mounts, while we can mount them directly to concrete, they're really susceptible to vandalism. So the district made us this box that we could attach our security box to as a much more permanent mount. But at a site that's as public as this, it does feel a lot better to have that special mount.
But then when we had the tunnels installed, we had cameras mounted into each end of the tunnel, so we could not only understand who was kind of using the tunnels, but also assess whether we had full passage.
Can you tell me a little bit more about this camera system?
It's the HALT camera system made by Michael Hobbs. The beam itself is narrow, probably like the thickness of a pencil. It sits very close to the top of this kind of ramp threshold. You know, so the ramp kind of forces animals to kind of cross to a point where they're going to intercept the beam, and the entity crosses the threshold, it triggers the camera.
So why is that infrared beam setup important in this case?
So reptiles and amphibians are ectotherms, they're kind of more cold-blooded animals, and so traditional game cameras don't typically trigger, you know, when a reptile amphibian passes by.
The Wildlife Tracker is basically a web application. Okay. So historically, our Endangered and Non-Game Species program has asked people who spot rare wildlife species across New Jersey to fill out a form and mail it to us, and you know, we were just sort of in the Stone Age in terms of wildlife reporting. So yeah, just recently we came out with this New Jersey Wildlife Tracker web application that's just a website that's, you know, friendly both on a desktop and on your cell phone, so that if you're out and observe a species of interest or concern, that you can take a picture of it, it'll know your location, and you can submit it directly to our program. So we're, you know, really increasing the amount of rare species data that we receive.
Dave, I see you have some track beds in here.
Yes, these track beds were established back in 2012, some of which needs to be maintained, but it really shows the example of what's crossing this area. There's turkey, white-tailed deer, raccoon actively passing through this corridor.
There was lots of pre-construction monitoring for this project. Being a new highway on a new location, you know, there was a potential for a lot of impacts if resources weren't avoided and impacts to those resources minimized. So yeah, we did a lot of habitat assessment for not just vegetation, but surveys for reptiles and amphibians. There was overnight bucket traps set up where you basically have a length of silt fence,
fencing, yeah,
and it funnels the reptiles and amphibians to a small pit that's lined with a bucket. So every few hours you check your pit to see what's in your bucket.
We have research money that's available for New Hampshire DOT projects. And so basically what happens is every 2 years they have a certain amount of money and folks all pitch ideas for projects. So this project was a wildlife vehicle collision study that we were looking to get a better understanding for where are the hot spots in New Hampshire. At the very beginning, we didn't have a lot of information to start them off with at Plymouth State University. The only reliable and more standard data source that we really had were the police reports. So it ended up being very skewed towards larger animals, but from a safety perspective at DOT, that is something we need to be really concerned about. And so at the end of the project, what they were able to produce for us was a map showing where have these incidents been over the last, you can look at 5, 10, and I think you can even look at 15 years, and see where are the highest concentrations of wildlife vehicle collisions being reported.
In Connecticut, they've streamlined the project construction process. When a project is already planned within the range and habitat of certain rare wildlife, instead of doing costly and time-consuming field surveys, they simply assume the species are present and plan accordingly.
We assume presence. So when we are early on in the project, we can keep the project moving. We have a specification that has protection protocols in place, and we can move forward with that going in the project contract and not have to be delayed with surveys and review of reports and preparation of reports. So that's been really helpful, and I think this project, some of that stems from what was done here.
Many other techniques are available for surveying wildlife. We heard about radio tracking bobcats in fragmented habitats in New Jersey, conducting winter tracking in the snow to find out where wildlife are crossing an interstate in Vermont, nighttime road searches for amphibian migrations in Pennsylvania, and electrofishing to determine fish presence in New Hampshire stream crossings. Many states have other mechanisms for considering connectivity in project planning and design. These may include state laws, regulations, design manuals, and guidance. Here are just a few examples.
Day to day, we're really lucky in New Hampshire. We have a state law that requires us at DOT to consider wildlife connectivity when we're planning our projects. And so that means as part of the environmental review that we have to do to be in compliance with NEPA, the National Environmental Policy Act, we actually go ahead and look for any known or mapped corridors or habitat strongholds in the project area when we're in the project design and planning phase.
So our land use folks in the DEP permitting side of things provide a flood hazard technical manual, which is available online. And that explains everything to do with flood hazard permitting, specs and things like that. And there is a chapter in there that deals specifically with wildlife crossings. And that has specs based on the species guild mobility, that has specs on what materials are best to use or what to avoid, and kind of how to put your plans together and sort of think about how to structure your project before coming in for the permitting. And it walks through what I was saying before of how our decision making, which includes publicly available materials like our tech manual and our landscape project mapping that will help folks who have those projects that are coming in start to think about that before putting their projects together and coming to us.
The State Wildlife Transportation Action Plan really got defined in the current infrastructure law, the BIL, and it encourages every state to work with their Fish and Wildlife Agency to come up with a plan, really an action plan, a strategy for how they're addressing resiliency, road ecology in their state or commonwealth. In many ways, it memorializes the work that we're already doing in a plan that our leadership can get behind and support to ultimately set a vision for the future. How do we invest in infrastructure when appropriate? How do we strategically think about where to incorporate connectivity and think about grants and other partnerships that can kind of come from there?
It's important to note that successful road crossings and habitat connectivity depend not just on road infrastructure, but also on having suitable habitat on either side of the road beyond the right-of-way. Ideally, that habitat should be protected from future development and fragmentation. This is how the expertise of many different transportation and conservation partners can come together, a topic we'll expand on later in this training. We hope you have found this brief overview of wildlife connectivity planning and prioritization useful. It's the critical first step in determining what kinds of crossing structures are needed and where, a subject we will look at next.